this is the last bit that we couldn't do, which is Python comments, indentation, and statements. We will be working more on indentation today as well, because it's something that's really important to, get the code working right. If there's a problem with the way that you indent it, it's not going to work properly. So unlike C++ and Java, Python does not use curly braces, which is one of the reasons that it's easier to write it and it's easier to read it as well. And there are lesser chances of errors because it happens a lot of times that when you've started a curly brace or any other kind of parenthesis, really, we forget to, close it at the end, and that gives us an error. Python does not make use of these for blocks of code, essentially. So it's one less line of code, let's say, or two less lines of code, and which is again what makes it more readable. But it uses indentation. So indentation is essentially a space before your code, which would help it identify what block of code is together and what is separate, essentially. We're going to see some code written, and then you'll have a better idea of what I'm trying to say. So this, again, is very important for Python. And if you mess up the indentation, or if you mess up the number of spaces before a code or a block of code, then the interpreter would not be able to compile and run it the way you would want it to. Okay, sure, Muhammad Azam. Okay, so like I said, a block of code is essentially a combination of the different kinds of statements that you want to be run at the same time, let's say. And your indentation, you used two spaces before the first line of that block. You should use two spaces before every line of code in that block. If you used four spaces, which is generally the rule of thumb, then you should use four spaces before every code, before every line. And if you're not giving proper indentation, it would give you an error specifically that says indentation error. Okay, and it would not be able to compile the code. Another one is comments. So like in the last lesson, we ended up writing some scripts to a file and saving them. And you would probably remember them for now. But if you look at it maybe a month later, 2 months later, or a year later, you might not be able to understand why you wrote what you wrote, or what the code was supposed to do, or the different variables or variable names that you had. What did those mean, and why did you name them that way, and lots of things, really. So a lot of programmers, and also especially a lot of
I'm back, ma'am.
people. Okay. So a lot of programmers and a lot of people who have actually started coding do use comments a lot. And I personally use them a lot as well, because they kind of help you explain the code and help you understand at a later point in time what you tried to write and why you tried to write it. And we use a special symbol before the comments, so that it tells the interpreter, in this case Python, to ignore it. So in the case of Python, it's a hash sign. A hash sign, as you see in the image below as well, is used before every line of comment. And that way, when Python reads the hash sign, it knows that anything else in that particular line, it's going to ignore and move on to the next line. So it's always good to have comments within your code at any number of places that you would like to put them in there. Not just for yourself, but if someone else is looking at your code, it's easier for them to understand it as well. Okay, so this is the way that you can add single lines of comments. There are ways in which you can add multiple lines of comments as well. We're going to discuss those. And again, like in Python, most of the code that we've written so far has been single liners. So we've written essentially what we wanted to do in a single line. But sometimes you want to write it in multiple lines. Uh, so for that, basically, each statement needs to end with a new line character. And then Python knows that it is not going to stop reading it and compile it and run it before it actually reaches the end of the statement. So we use a slash for that. The slash character lets Python know that we're still writing the code and it should read the next line and the next line till it doesn't read in any more of the slash characters, and then it can compile and run it. So this is just a way of writing multi-line Python statements. We don't really need it because statements in general are already shorter in Python. So it doesn't really, make a lot of sense to write them in multiple lines. So moving on to today's lesson. So again, I've written down the course outline again. Today we'll be looking at different Python collections and condition blocks. We'll be looking at lists and dictionaries and some other data structures in a little more detail. And then we'll be looking at conditional statements like if, else, and else if. And again, it's going to probably be a lot of concepts today, but I will try and take it slow. You can always stop me in the middle if you think it's getting a little overwhelming. We will also be taking a break in the middle as well. And I will try and keep it as simple as I can. Okay, I'm leaving in my contact again. So we studied about data types in Python in the last lesson as well. We looked at numbers in quite a bit of detail and the different functions that we can use on numbers. We also looked at strings and multiple ways of, using quotes within strings and how the different functions we can apply to strings, like the length and the uppercase, lowercase, and a lot of comparisons as well. So is alpha and is digit and all of those. Another data structure that we looked at was lists. And we're going to be looking at this in more detail today. So lists essentially, like I said, was a collection of items in a particular order. And it can include any number of letters of the alphabet. It can include digits. It can include, for example, the names of all the people in your family, the names of colors, fruits, vegetables, anything really. It can be a mix as well. So it doesn't have to be just names. It can be a mix of numbers and names and a combination of the two. So you can put down anything you want in a list, and the items in the list do not need to be related. So there is no condition of them to be related in any way. And these are separated by commas, and these are enclosed within square brackets. So as you see in the image here as well, for example, the list by the name of assets has the contents computer, printer, TV, and camera, and it's the different components are separated by commas and they are enclosed into square brackets. The same way for a list named scores, for a list named letters. So again, this is also to tell you that you can use either double quotes or single quotes. It doesn't matter because for Python, both of them would be considered strings. And now this is like a list that has a combination of strings and digits. So a list can have either. Now Python has a number of built-in methods that you can use on lists. I'm not going to go over a lot of these in the shell because you have an idea now of how to go about these different functions. We went through them with numbers, we went through them with strings. So I'm going to let you experiment with these on your own. I will be explaining what each of these does, but we wouldn't be practically doing them unless you want me to do them later on in the class, okay? So some of the built-in methods that you can use on lists are append. So this adds an element at the end of the list. Clear removes all the elements of a list. Copy returns a copy of the list. So you can either save this in another variable or just save it into memory for there and then. Then count returns the number of elements with the specified value. So for example, if your list has 10 entries or 20 entries, and whatever is held at each entry, essentially. Extend, it adds elements of a list to the end of a current list. So you can basically join two lists together. Index returns the index of the first element with the specified value. Insert adds an element at a specified position. So if you want to add something to the middle of the list, maybe. So like the append function, it adds an element to the end of the list, but you want to add something to the middle of the list or to the start of the list. So you can use the insert function and specify where you want to add it. Again, you need to remember that these use indexes, and indexes always start at 0. Okay. Then pop. So a pop removes the element at a specified position again. If you haven't given a position, it's going to remove the last element of the list or the last entry in the list. And if you give it a position, it's going to remove the element at that specific position. Remove works the same way. Reverse reverses the order of the list. So whatever order it is in, it's simply going to, write it down in the reverse order. Again, you can save it in another variable, or you can just reverse and output it to the screen. And then sorts the list. So you can sort a list into ascending or descending order. Again, a list can have numbers and characters, alphabets and all of that. So there's ways to sort them. So here are some examples again of how functions are applied to lists. I've also left a link here. I have taken a lot of the images used in today's lesson from this page, also a lot of the examples, because they were easier to understand. I have shared a few more images and with them their links in the lesson. You can have a look at them later on, and here you'll find a lot more detail than I would probably be able to teach in the lesson. So in lists, we can take portions, including the lower, but not the upper limit. So for example, if you have a list of, let's say 100 entries, and you just, for your specific exercise, you only want the first 20 entries. So you would need to splice the list. So instead of reading in the list of the whole 100 entries every time and then working on it, because it's going to take up more memory, take up more time. So what you can do is you can splice it or slice it and make a smaller list of maybe the first 20 entries or the second 20 or the last 20 entries. And that would be a subset of the list, and then you can work on it. So that's going to save you time and save you memory in terms of how long it takes for, or how much memory your actual program is going to take. So a way to do this is, again, using the indexes. So anything that starts from the first index you give and your list stops splitting at the last index. And it does not take in that value. So for example, if you had a 0 to a 10, it's actually going to give you the items from the first in the list to 10 minus 1 index, which means essentially the 10th item, but the 9th index. Okay. And if you want from a certain start position to the end of the list, wherever it goes to, this is what you use. If you wanted to begin at the starting of the list, but let's say the first 20. So you put in the 20 here. You don't give it a start one. And if you want to copy the whole array or the whole list into another one, you can simply do it without a start and a stop position. So like we discussed earlier as well on the remove and pop functions, there are essentially three methods that you can use for deleting list elements. So there was the remove function, there is the pop function, and there's also a delete operator that you can use. So here are examples of how it would work. So the remove method takes a particular element to be removed as an argument and deletes the first occurrence of the number mentioned in its arguments, or it doesn't have to be a number, but a string or anything. But what is important is, and what I highlighted here is, that it deletes the first occurrence and the first occurrence only. So it's going to go through the list, and the first time that it found, like for this, it says vowels, so which is the name of the list, dot remove, and then the argument you gave it was an A, which means that it removed the first A. If there was an A at the end of it, it would not have removed it. It would just remove the first occurrence. So what it gives you now, if you print the list, is EIOU. Okay. The same way, pop and delete take the index of the element to be removed as an argument. So if you say print, now this here, if you notice, they're combining two functions. So you could have done vowels dot pop and one in the bracket and then printed vowels, or you can combine it in one, like we've been doing in the past as well. So they've combined both of them here, and they're saying they want to take out whatever element is at index 1. Again, I would like to remind you that indexing starts at 0. So E is at index 0, I is at index 1, O is at 2, and U is at 3. So when you said vowels.pop1, it took out what was at index 1, which is an I. So what you get now, if you print the whole vowels, would be EOU. And if you printed just this, vowels.pop1, it's going to, like here, it's just going to give you an I. So it's going to tell you what it popped out. The same way, delete A colon B deletes all the elements in a range starting from index A to B. Again, you can use, instead of using just one argument here, you can use a starting point and an ending point. So if you want to delete maybe the middle 10 entries of a list, what you can do is you can give it a starting point and an ending point, and it's going to remove it from there. Then there's the clear function. This is used, like I said earlier as well, to erase all the elements of the list, and after that the list becomes empty. So if you do vowels, which is the name of the list, dot clear, and then try to print it, it's going to print an empty list. Okay, so we talked about the sort method as well. Again, I'm going to show you the examples here, and I'll let you experiment with these in the shell in your own time, and then you can come back to me if there are any problems that you run into. So the Python list implements the sort method for ordering its elements in place. So they can be ordered into the ascending sequence or the descending sequence. And there are different ways to do it. By default, if you use sort, it's going to sort it into ascending sequence. So we have a list A, E, I, O, U, and we sorted it since it was already in an ascending order. When you print it, it's going to essentially print in the same order. Now, if you want to sort it into a descending order, what you say is the list dot sort, and then you give it the argument reverse equals true, which essentially means that you want to reverse it. So by default, reverse equals false, and you don't need to write it. But when you want to sort it to a descending order, you write reverse equals true and then print it. And what if you notice the output here, what it's done now is it's sorted it into the descending order, and it's essentially printed it to the screen. Again, what you can do is you can also save this particular list as another list. Give it another variable name and then save it as that and print that as well. There's also a sorted function that you can use, which works the same way essentially as the sort function. And again, the syntax varies a little. So here you did the name of the list dot sort, and here you do sorted, and then the name of the list comes within brackets. And if you wanted to sort in the reverse order or in the descending order, it's sorted, and within brackets you write the name of the list, a comma, and then reverse equals true. So essentially sorted and sort both do the same thing, are built for the same function, but their syntax varies a little. So it's your choice entirely which one you're more comfortable using. Okay, I think that's about it for lists. There are a lot of other functions that we can use on lists, but I think I'm going to stop here for the lists part, and then maybe later on we can come back to it. Another data structure that I probably did not talk about in the last lesson was tuples or tuples. There's both ways that people say it usually. So it's essentially like a list with two key differences. One, that it's immutable. So immutable means that you cannot, once it has been created, you cannot change the contents of it. So for a list, you can change any of the contents at any time, and you can delete and add contents to it. But once you've created a tuple or a tuple at the start, you can't change its contents. So you have to be careful when you're actually making it, because you can't change it later. And as far as syntax goes, a list, as you remember, was created using square brackets. But this is created using round brackets or parentheses. So these are the examples of the same. So assets, scores, letters, and things. So like lists, you can have strings or single alphabets or numbers or a combination. It can hold anything just like a list, but the only difference is that one, when you create it, you use round brackets, and two, once you've created it, you cannot change any of the elements in it. You can access it, you can run operations on it, but you can't change it. So again, there are a number of other methods as well, but some of the main methods that we use on tuples are the index, which searches it for a specified value and returns where it is. So it returns the index for it. And then the count, which essentially returns a number of times. So whatever argument you've given it, it returns a number of times that it found that within the list or the tuple. Again, I'll probably be repeating this a number of times, but unlike lists, the items cannot be deleted by using the delete keyword because they're immutable. So even if you use it to, so if you need to delete an entire tuple, you can use the delete keyword with the tuple name, but you cannot give it this argument. So if you tried deleting, let's say index 0 of it, it's going to give you an error. But you can use it with just the name and it would automatically delete it. So here are some examples of how you can work with tuples. So the first one is create an empty one. So they named it py underscore tuple, and essentially it's a empty or a blank one, and they've printed it. The output you can see here. Then create it without using round parentheses. Now this isn't recommended, but I think some of the newer versions of Python do allow it. I'm not sure how wise it would be to do it this way. I haven't tried it. I haven't tried running it this way, but you can give it a try. And then if you run into any errors, we can have a look at them. But again, maybe if you're using an older version of Python, it might not allow you to create it without using round brackets. It might give you an error. Okay, so now they've created a tuple with numbers and they've printed it with mixed numbers. So what they're telling you is that you can, within the same, like we've discussed earlier, you can use strings, you can use single alphabets, you can use numbers, and then within numbers, you can use the integer or the float or the imaginary number. So you can use a mix of them as well. So with mixed data types, it's essentially done the same way. And if you notice here, so the first data type is a number, the second data type is a string, and the third data type is a list. So within the tuple, they added a list as well. So a number, strings, and lists. So you can have lists within lists as well, and you can have tuples within tuples, and then lists within tuples as well. Okay? And tuples within lists. So it works either way. And then create a tuple of tuples, that is a nested tuple. The same way we call them a nested list if you're putting a list inside of a list. And this is how you would tell it. So essentially, anything in the round brackets here, this is one tuple. And then here is another one. So the first one had small x, small y, and small z. And the second one had capital X, capital Y, and capital Z. And so a tuple of tuples is XYZ, XYZ.
Excuse me.
Yeah.
Do we always name it like py slash under root and slash sorry underscore tuple, or we can
No,
name
no,
it
no. You can name it anywhere really.
anyway? Okay. And
Yeah.
how would you differentiate that this is a tuple and this is not a list? I could not distinguish.
No worries, no worries. Because when it's a list, it's you. When you're declaring it, you're going to use square brackets,
Okay.
and when
For
it's a tuple, you're going to use round brackets.
bound breakers. Okay. Okay.
Yeah.
Thank you.
So there's only a very slight difference,
Mhm.
but it changes the entire data structure essentially.
Okay. Thank you.
Welcome. Okay. So again, you can access the different elements within it. You can index the first element using the zero index again, which means the first element. So this was a 0, 1, and a 2. This is the 0th index for the first tuple or the main tuple. And then within it is this tuple. So this was the whole tuple. The 0 index had January, February, March. And the first index had Sunday, Monday, and Wednesday. So when you're writing a 0 here, you're accessing the first tuple, which is the January, February, March one. And the second position here tells you which entry within this you would like to access. So it was a 0, 1, 2, which is March. And if you see here, it's given you a March is output. The same way here, TOT1, which means you want to access the tuple, which is in the first index position, which is here, and then a 2 out of this. So this was again a 0, 1, 2 would give you a Wednesday. So the output is a Wednesday. More examples again. I hope I'm not confusing you so far. I know the indexing can sound a bit confusing, but once you start writing it out in your programs, it is actually quite simple.
Yes,
Take a
it's
look at.
getting a bit complex, and I think if we can do some hand-on exercises along, then it would be beneficial, I guess.
Okay. So let's go through all of this once, and then we can try and do some hands-on exercises. Okay. Okay, so this is another example here. It's a tuple by the name of weekdays, and it says Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And this essentially shows you the indexing as well. So if you want to access all the elements leaving the first one, so what you want is to start at index 1 and then go to the end of the tuple. This is the result that you get. Here again, if you notice the hash and the text here, so they've added in comments in each part to tell you what this command would be doing. So now you want to access the elements between the first and the fifth positions. This would include the first. This would exclude the first and the fifth. This is how you do it. Accessing the elements after the fifth position. So you give it a starting point and tell it to go to the end. Accessing the first 5 elements. So you don't give it a starting point, which means it starts at a 0, and you give it an ending point. Again, accessing elements appear after counting 5 from the rear end. So you can do this for any number of elements from the rear end. If you want the last 5 entries, it's going to be a -5. If you want the absolute last entry, it's going to be a -1. If you want the last 10 entries, it's going to be a -10. So accessing the 5 elements from the rear, okay, I think they've messed up the comment here. But essentially what this should do is the same as this. Again, we're going to try it, as Fatma suggested, on real time as well, and see how it works. Okay, and accessing all the elements from the start to the end, so you don't give it any start or ending point, and it's going to give you the whole as an output. The next data type we're going to look at is sets. So sets again are also like lists. So there are 4 things essentially that have more or less the same functionality with only small differences. So there's lists, there's tuples, there's sets, and there's dictionaries. I did tell you a bit about dictionaries in the last lesson as well, and we're going to go into a little more detail of that today as well. And once we're done with these data types, we're going to go to the shell and try creating them and working on them as well. So sets are also like lists, like I said, and essentially what they are unordered and unindexed. So whatever you put in there, essentially every time you print it out, it's going to print out in a different order. So like in lists, once you created them, you could change them. You could change positions within them, or you could change the contents. But whatever you wrote was in a specific order. In sets, it's in no specific order. So there's no index positions assigned to each argument within it. So each item in a set is unique, and therefore it cannot have duplicates. Again, this is also important. Like in lists, for example, if you were making a list of colors, you could put in red 3 times and yellow 2 times, or any other color any number of times, or for anything else as well. So you can have duplicates in your list. But for sets, you cannot have duplicates. So like I said, there's slight differences between these 4 data types, and there's different places where they are used. But for me, like myself, I like to stick with lists for most part because it's just kind of a hassle remembering all the syntax for all the different data types. So again, the elements are immutable, which means once it's been created, it cannot be changed. But the set itself is mutable. So you can add or delete items to it, but the exact items cannot be changed. Okay. And within Python, sets are written with curly brackets. So if you remember so far, the lists were written with square brackets, the tuples were written with round brackets, and now the sets are written with curly brackets. And the built-in methods are more or less the same with sets as they are with the lists and the tuples. There may be slight differences. So an add uses adds an element to the set. Clear removes all the elements from a set. Copy returns a copy of a set. So we've seen similar ones in lists as well. And then there's, which we're going to look at a little more detail later on as well. So there's a difference and there's a difference update. So a difference essentially returns a set containing the difference between two or more sets. So it takes in two or more sets as an argument, and we're going to see the example of two sets, and it returns the difference between the sets. So they may have similar values, some of them, and some may be different. So what it's going to return is only the differences. And a difference update removes the items in the first set that is given as an argument that are included in another set. So again, this takes in two sets as an argument, and it removes the items from the first set if it found them in the second set, or vice versa. And then discard removes the items in this set that are included in another specified set. So this essentially is the same as difference update. Then there's intersection update. Now this may sound a lot more, maths intensive, because we read about or learn about sets and maths, and the differences and the intersections and the unions and all those. But when you're working with lists and sets, you'll see that these do come in handy when you're working, especially with large data. And you don't want to, because for smaller data, you can probably just do it by hand as well. But when you're working with large data and you need to compare them, it's easier that you have these functions built in to be able to compare and find the differences. So intersection returns a set containing the difference between sets. And like the difference update, the intersection update, what it does is removes the items in this set that are not present in the other. So is disjoint returns whether the two sets have an intersection or not. So this is going to return true or false. Is subset, again, this is going to return true or false, whether or not the other subset is a part of this set or not. Is superset, again, is going to return true or false. So if this set is a superset of another set, it's going to return true. Pop, we saw this in lists as well. It removes an element from the set. If you haven't given it an argument, it's going to remove the last element. If you've given it an argument, it's going to remove a specific element. Remove works the same way, and you need to tell it what element you want to remove. Then there's the symmetric difference update, union, and update. Okay. So we're going to look at the union. So for those of you who, I'm not sure about Muhammad Azam, but you might have, come across at least the basic concept of a set in your previous grades. So essentially what a set is anything that has a certain number of elements in it. So it could be numbers, it could be alphabets, it could be strings, it could be anything really. So we're going to look at a union of sets. So a union is found by combining two sets. So by using the union function, what you do is you combine all the elements of set A and set B. And what it does, uh, which is a built-in property, let's say, of this function, is that if there are any repeats, it deletes them. So like we said earlier, a set cannot have duplicate values, right? So what we saw in the introduction. So when it's combining two sets and it finds any duplicate values, it's going to keep one copy of the value and remove the other copy. And for union, we use this straight line. I've forgotten, I don't know, it's slipped my mind what we used to call this, even though I've used it so many times. And or you can use this union function. It's both of them are going to give you the same result. So let's see, we'll look at two sets. Set A has A, E, I, O, U, G, H, and set B has A, E, Z, B, T, O, U. So you might notice that some of the elements are similar in both sets. So we have A in both sets, E, and we also have a U and an O in both sets. So what we're doing here with these commands is we're telling it to print the initial set A. So within this, it's going to print this as is. Then it's going to print the contents of set A. Then it's going to tell you what the size is by using the length function. Now you've used the length function earlier for finding the length of strings as well. And we saw how we can use it for the length of lists and the length of tuples. So it's essentially the same syntax, len, and then the name of the set. And what it returns is that your initial set A was UIGOEHA size 7. Now, if you notice here, it's not giving you the set in the same order. Here, if you see, the order was A, E, I, O, U, and then G, H. But here, it's mixed up the order. And when you print it the next time, it's going to mix it up again and again and again. So every time you print it, it's probably going to give you a different order. Again, that's because the order within sets is not fixed. It's unordered and unindexed. Similarly, for set B, when you try printing it out, it's going to give you a random print. It's going to show you all the elements. It's not going to miss out any of the elements, but it's going to give you a random, let's say, sequence of the elements every time that you print it. And it tells you that the size is 7. So the size for both is 7. Now, if you have 7 candies in one hand and 7 candies in the other hand, and you're combining them, you should get a 10. Oh, sorry, you should get a 14, right? But what union does is that it deletes any of the repeats. So we noticed that there were 3 repeats or 4 repeats. So A, E, O, and U were repeated. So if you notice here, it's only written U once, similarly O and E and A once. So all of those elements that were a repeat in the union set, you will only see them once. It's deleted the repeats. And now it's telling you that the size of this set is 10. So it's deleted one set of the repeats. Any questions?
Ma'am, I have a question.
Yeah.
I didn't understand why instead of 14 there's 10. For like, is it because like the maximum is 10?
No, no. There is no maximum really here. It's because we noticed that 4 of the elements were repeated. So A, E, and O, U were repeated, right?
Yes, but how?
So in both sets, set A, there was an A as well as in set B. Similarly for E, it was in set A and set B as well. Similarly for O and U. Okay, so all 4
Oh,
of
okay,
these,
okay. I understand now.
yeah.
I understand. I
So
understand.
it's basically deleted the repeats.
Okay, I understand now.
Okay.
Like because you can't have double to ruin it all. That's why like we cut it
Yes,
these.
yes.
I
So
understand. Thank
because
you.
you're welcome. So remember that a set cannot have doubles of any value. So it only can have unique values. So similarly, an intersection. So an intersection essentially is the same way that a union gave you everything that was combined in 2 sets. An intersection gives you the common elements in both the sets. So we're going to work with the same sets, and for intersection, we can either use the AND operator or we can use the intersection method, and it's both going to give you the same results. And here it shows you the usage of both of these. So if you're looking at the same sets, A, E, I, O, U, G, H for set A, and A, E, Z, B, T, O, U for set B, this is essentially the same. You print the sets and their sizes, which is a 7 and a 7, and then you want to print the intersection. So you can either do set A and set B, and then that size, or you can do intersection BA equals set B dot intersection set A. So there's a little difference in syntax, and it's your choice completely. It's easier to use this one because this is a shorter syntax, but again, it's your choice, whichever one you prefer. And what it would give you is what is similar between the two sets. So we noticed that A, E, O, and U were the elements that were similar. So in the last one, it deleted the similar elements. And this one, it's going to give out the similar elements as an output. So intersection means in maths as well, and for Python, common elements. So whatever is common within both sets. Now again, sets can be made using numbers, and sets can be made using complete strings. Sets can also be made using, floats and complex numbers. And whatever kind of data type that you are using, it's going to compare them, and it's going to give you an intersection, or it's going to give you a union. So it would work with any one of these. So when we do it on the shell, we're going to try and do it with numbers so that we can, look at how it works with numbers as well. So the third one, and after that, I think I'm going to give you a break before I move on to dictionaries. So the third one is the difference. And when you perform the difference operation, it would give you, the same way that you do a subtraction in math. So it would essentially subtract one set from another. So you would tell it what two sets you want to compare, and it would subtract the one on the right from the left. Okay. And we use the minus operator the same way as we use when we're doing simple subtraction, or we can use the difference method. So what we simply do is we subtract set A minus set B. So if we were to take out set B from set A, what would you get? And you can again either do it using the minus sign, or you can do it using the difference method. It's easier, it's simpler to write it simply as a subtraction rather than to write it in this form. But again, it's your choice completely. And when you subtract it, it's going to give you this output, and it's going to tell you what size it is. Now, what it's done here is, if you notice, set A minus set B. So set A was A, E, I, O, U, G, H, and set B was A, E, Z, B, T, O, U. So when it subtracted this one from this, it's going to delete all the elements that it could find in set B. So it found A within set B, so it deleted that. It found E, it deleted that. It found an O, deleted that, and it found a U, deleted that. So what's left now is the I and the G and the H, which is what it's given in the output here. Similar way, set B minus set A. So it found an A, so it deleted that, an E, deleted that, an O, deleted that, and a U, deleted that. So what was left of set B was a Z, B, and a T. And again, you can display the size of whatever it was.
Oh, ma'am, I understand like why only A, I, G, H, and Z, B, T were left.
Okay, you don't understand?
No, I understand. Can I like explain to the class? So I understand that like only I, G, H would be left because you can see in set A and set B, A, E, O, and U, all of these like letters, they have like doubles, and so they will be like cut and minus. So what was like only I, G, H will be left.
Yes. So
And then
those
set
were the
B-
ones that were different.
And then set B, A, again A, E, O, and U would be deleted, and only Z, B, T would be left. Z, B, T, and I, G, and H are the only like variables or letters that don't have like any doubles.
Yes, yes, that's correct. Okay, so I know this is a little confusing again, and maybe too many concepts at once. Okay, so let's start by creating a list. Let's say a list of colors. And for a list, we use the square brackets. Okay, I think that's enough for now. So we've initialized a list, and the way that we know it's a list is because we've written it in square brackets and we've given it the name colors. So to start with, we're just going to try and print this. And what it returns is the list in the same order that you created it in. And that's because each element in the list has a specific position assigned to it when you created it. Now, there's different operations that we can try and run on this. The first one, let's try, accessing specific elements using indexes. So let's say we want to print index number 1, which is going to be the second element. So it should be an orange. Yeah. The same way, let's say we want to print the last index. I think we should be able to access it using -1. And yes, it prints us a black. Now to access a set of elements, so we give it a starting position and an ending position. So it's printed everything from index 1 to 4, essentially. It skips out the 5th one. Okay, so does everyone understand the use of indexes?
Ma'am, can you please repeat how does this -1 works?
Okay, so -1 is essentially when you're trying to access the last element. So it is the same as, it would be the same as length -1. So you can either
Okay.
write length -1 or simply -1.
Okay, yeah, thank you.
Okay, you're welcome. Okay, so now let's see, we want to add an element to the list. So
Ma'am,
we
I have a
read,
question.
yes.
Will it be fine? I only wrote the colors red, orange, yellow, and green. I didn't write blue, pink, purple, and black. Will it like affect it?
No, not really, unless you're using the indexes properly, it shouldn't be a
Yes,
problem.
I'm using the indexes properly, but like I didn't write blue, pink, purple, and black.
Yeah, that's your choice completely. If you want a long list or a short one, or however you want to play with it. I just kept like a medium length list so that we could, try and remove some elements, add more elements, and work around with it. Okay, so now let's try adding an element. So if you remember, we read the append function. So how we use it is, we put in the name of the list, then dot append, and then we given the argument of whatever we want to add. So append essentially means add at the end. So whatever we want to add, let's say want to add brown. So now if we print this list, it should give us brown as well. Yes. So if you notice now, we've added another element at the end of the list. The same way you can add multiple elements. Oh, okay, no, it should work differently. Again, it varies with different versions of Python that we're using. This used to work in the older versions, but I think they've changed the syntax for this one. So we can't add more than one argument using this. We'll have to add it using a different function. I will let you know what that function is as well. Okay, I'll let you know about that in a bit because I have to search it myself as well. So if you're using an older version, you might be able to do it like this, but it appears so that in this version of Python, we can only add in one more element using the append command. Okay, so now
Ma'am,
if you want,
ma'am, one question. I wrote everything like when it said traceback, the same red thing. I think it's because like I have a new version, not an old one.
yeah, so that's why you're getting this error as well, because they changed the syntax a little in the newer versions. and they add more functions. So they've probably added in another function specifically to add multiple values instead of using the same function. Okay, so I'll have to look for it, and then I can, let you know in a bit what that was. But, for now, let's try and remove some elements from this list, or let's say insert an element in a specific position. So right now, what we did with append was we added something to the end of the list. Now, let's say we want to add something to another position for the list. Let's try that. So colors dot insert. I hope it works in this version because it does work in the older versions. So let's say we want to add something to index 2. Okay, so 2, and then whatever we want to add. So let's say white, and it should work. Fingers crossed. Yes. Okay, it did not give an error, which means it's probably worked. Let's print out colors and see if it's added it to the right place. So yes. So you see we told it to add white to index number 2. So what it's done is 0 and 1 remain the same. It put in white at number 2 and it pushed all the rest further down. So it pushed all the rest one index forward, and it inserted white, the color white, at position number 2. Okay, so the same way you can add or insert essentially things at different positions within the list.
One question, ma'am.
Yeah.
So this is actually to your previous comment that they probably have updated the syntax in the newer version.
Yeah.
So yeah, if they keep on updating the syntax, how would you know that what is the new syntax? And I mean, do you stick always to one version of the compiler, or
Well,
yeah.
yeah, well, generally you don't need to, if you have one version installed, you don't necessarily need to keep updating the versions as they come, because you've kind of gotten used to the syntax and gotten used to the functions that are in there. Because yes, this does vary, especially because the last time I used Python, like I said, I'm more of a regular Perl user than I am a Python user. So the last time I used Python as regularly as these days was at least 5 years ago. So there have been many changes since then till now, and there have been multiple versions that it's updated on.
Yeah.
If you've been using it recently, there's only going to be slight changes. There's not going to be any drastic changes in the syntax. But yes, every time there is a change, you will get an error like this, and you will have to go back and check what happened wrong and what the new syntax is. So there's lots of forums and lots of help pages online that can give you the details of the function.
Ma'am?
Yes?
I want to tell you, even if you write colors dot insert and all the colors you want, if you write insert, not append, it will still show this red thing.
Okay, yes, because the insert is used to put in, add in one element to a specific position. So you can't add multiple elements using insert. The same way that append is used to add one element, insert is also used to add one element.
Okay, so ma'am, if you want to insert white and peach and violet, would you write 2 for white and then 7 for peach, and do you write a number before the color you want to put?
No, not in the same using the same function. You would have to use a different function for that. Let me just give me a second to find out what that is. Okay, so what you can also do is probably, let's try this. Let's make another list, more colors. And then I think this should work. But again, I'm just trying it out with you as well. So please pardon me if it doesn't. Okay, no, it didn't work. Okay, yes, I think I should not, rush through this. I'm going to look for it and share it with you later on, okay? Let's just move on to removing elements from a list. So there's two different functions that we read about. There was the pop function and then there was the delete function. So let's say we want to try out the pop function first. So
Can anyone hear me?
yes, now I can.
Hello?
Hello, yes, I can now.
Yeah, I can hear you. Okay, good.
Okay, so let's make a new list. In which we are basically popping out a value of out of colors, okay? And then print the new list. So what this did was, did we? Okay, apparently this extend function worked and it did add it, just did not print it. I'm going to try and print the list again. Print colors. Okay, so this is what we have in the list colors now. So the extend function worked, you just could not use it with the print command. So when you tried to print it in the same command, what it did was it displayed none. But if you notice on my shell, I printed the list colors and it shows peach and violet added to it as well. So now if we're going to try and do it again, we do colors dot pop. And what this should do is this should remove the last element from the list. So it should remove violet. And it's given you this as the result. So dot pop removes violet. And this is what you see here. Now you can either save this in the form of a new list, or you can save the remaining list in the form of a new list. And there are different ways to do it. The same way, you can remove using the delete function or del. So how that works is,
Ma'am,
yeah.
can you make like a new idle shell, because like I'm not in full screen mode and I also need to like copy what you're writing.
Okay. It's not going to clear it out this way. How about okay. Can you shift to full screen mode? Or can you see it now?
Yeah.
Yeah, is that better? Okay. So the other function we read about was delete, and using the delete function, what you do essentially is that you give it an index space that you want to delete. So pop remove the last index, and if you want to remove a specific index, you use delete. And what you write is del, which means delete is short for delete. and then colors. And let's say you want to remove index number 3. So it's 0, 1, 2, 3. Index number 3 should be a yellow. So when you print it out later, there should not be a yellow in the list, okay? So it's deleted index number 3. Now let's print this list and see if it has worked.
Ma'am, for me in number 3, I got deleted from white. My white deleted.
Okay, did you have white at number 3?
Yes.
Okay, that's fine. So if you print it
Okay,
out
ma'am,
now,
another question.
yes.
Why didn't you count red? Like red is 1, orange 2, and white is 3. Why didn't white delete instead of yellow?
Because indexes always start at 0. So normal
Oh,
numbering
okay,
starts at 3, but indexes start in 0. So red is position 0, orange is position 1, white is position 2, and yellow is position 3.
Okay.
Okay. So now you
Yes.
see that I've printed the list again, and yellow, which was at position 3, is no longer in the list. So this is how you can delete specific elements in the list. Another interesting thing that you can do is, for example, if you don't remember the index number, but you remember the names of the things in the list, and you want to remove it based on that. So colors dot remove, and you tell it what you wanted to remove. So let's say you want to remove purple. Okay. Now, if you print the list, it should have removed purple from the list. Yes. So if you notice now, it's removed purple. So there are 3 ways to remove items from a list that you've seen so far. There's the pop command that removes the last argument or the last element essentially in the list. Then there's the delete command, in which you can give it an index and tell it to delete whatever is on that index. And then there's the remove command that if you don't know the index, or if you don't want it to be just the
I
last
think I
element.
should have written more colors, because now I only have red and white left.
So you can try removing red. So then you'll have just one element in the list. And that's okay. This is just, just for practice. Okay. So these are the 3 commands that you can use to remove elements from a list. And then if you want to clear out the list completely, do you remember the command for that? Does anybody remember?
To delete the whole list, all the information?
Yes.
I thought it was DE. I think it was DEL dot list. And
Okay.
what do you call this thing?
Index?
No, not index. The thing that is in 9 and 0, and you press shift to do the
parenthesis?
Yeah. Sorry, I forgot. I think it's clear dot list parenthesis, 2 parentheses.
Okay, let's try that. So clear dot the list of the name is colors. Like this?
No, I think it's clear dot colors list, and then these 2. Wait, I'll try.
Okay, but yeah, because the name isn't colors list, the name is colors. I think it should be this way. Okay, so clear colors. Okay, this gives us an error as well.
It will be colors dot clear and the 2 brackets.
Yes, we can try that as well. Colors dot clear, and then like this.
Yeah.
So yes, it's cleared it. Now if you print colors, what would it return?
Empty square brackets.
Nothing.
Yeah. So there's still a list there, but there's nothing in the list. So the list still exists in the variable colors, but there is nothing inside of that list. Okay.
Okay. Ma'am, a question.
Yes.
How do we delete like all of the information you wrote on this idle shell, that everything? How do you delete that? Like, what's the command for it? All of this things.
Okay, I couldn't actually find a command for it. The simplest way I found it was to, press X and then open it up again. Because there is a command for it, but it's apparently too complicated. And it's just easier to close the window and open up a new window.
Okay. What about like if you press shell and then it says restart shell, what will happen then?
It's going to just restart it in the same position. So shell, restart shell. So what it's done is it's restarted it. Essentially what this means is that any variables that you had declared before this are all gone now. So they're all gone from the memory.
Okay.
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 Okay, so there's some other functions that we want to try on lists before we move on. So I'm going to use the same list again. I'm just going to copy paste. Okay, so now if you print it, you'll see that we have this as a list again. Okay, now if you notice, these colors are not in alphabetical order. So what if you want to print them in alphabetical order? What do you do? What was the function? Does anyone remember?
Ma'am, when I did print colors, why did it say the red thing?
Did you make another list by the name of colors, or?
Yeah, I made another list.
Okay. Are you sure there is what error did you get? What does it say in the error?
It says that the file could, I think it's because when I like restarted the shell, I didn't copy paste.
Okay.
I'll try to copy paste first. Paste. Oh yeah, now it came. I think it's because when I restarted the shell, all of the information from the last shell, like it doesn't come. You have to like restart everything.
Yes, yes. So all the variables that you had declared already are gone from memory. Okay. So we've created a new list, colors, we printed it, and now we're going to try and sort it. So the way we do it is colors dot sort, and it should have sorted. Now, if you print it, if you notice, it sorted it into alphabetical order. Yeah. So by default, the sort command sorts any list into, or any tuple or any set for that matter, into ascending order. Okay. So if you want to sort it into descending order, what you do is okay, this was like this. So yes, again, like I said earlier in the past two lessons,
Whenever
Python is
another thing.
yes.
Whenever I'm writing, whatever you're writing, it always like when I press enter, the red thing comes. I think something is going wrong. Like, can I share my screen and show you?
Yes, I'll just stop sharing my screen and then you can share your screen. Yes, please share your screen.
Okay. Can you see?
Okay, so okay, so go down to your last restart. So it says name.
I don't understand what's happening. It's very complicated.
Okay, it's told you that, and it's telling you repeatedly that the name colors is not defined. So first you need to define a list. You know, like I did, colors equals.
Colors is equal to then all the colors and like that.
Yeah, the square bracket, start a square bracket and write the name of a color. So yes. Yeah,
I think
so
I'll
this
write
should be enough.
No,
Okay,
I'll write 5 so like it can carry on.
Yeah, sure.
And
Okay.
so what should I do now?
You forgot to close the bracket. No, the other bracket, square bracket. So when you started with the square bracket, it should.
Okay, I have to write this all again, you mean?
You can just copy paste. Control C, yeah, or right click. Paste and then write a square bracket at the end. Yeah, enter. So now print. And within bracket, write colors. So now round brackets.
Okay, thank you very much. Can I stop sharing?
You're welcome. Yes, you can.
How do we stop sharing? How do we stop sharing?
You should see at the bottom of your screen, stop share, or at the top of your screen. It depends what you're using. You see a red bar. Yes.
Yeah, did I stop sharing?
Yes. Stop sharing. Yes.
Okay.
Okay, so I'm sharing my shell again. So what we did in the second part was for the first part, we did a simple colors dot sort, and it sorted it into ascending order. And then we tried sorting it into descending order using the same command, colors dot sort, but within brackets, we told it to reverse it. So reverse equals true. By default, reverse is false. You don't need to write it. But when you want to sort it into a descending order, you write reverse equals true. And if you notice now, it sorted the list into a descending order. Okay, so the same can be done using the sorted function, which I mentioned, and it's there in the slides. You can try it out. Okay, so we haven't.
Ma'am, after I wrote like colors dot sort reverse and print colors, like all of the colors, it started to mix up.
Mix up? How?
Yeah, for example, before it was red, blue, indigo, pink, and green. Now it's red, pink, indigo, green, and blue. Like they mixed up when I wrote colors dot sort reverse is equal to true. Now learn colors.
Okay, I'll stop sharing my screen. Can you share your screen again? Because this way I won't understand. It's okay. We have time. We can.
Okay. Sure. Can you see?
Yes.
This is what I did. After like I did this, I did colors dot sort reverse is equal to true. Then like only this skin. Then I wrote print colors and like the colors mixed up.
No, they're not mixed up. They're actually sorted in the reverse order. So if you.
Yeah, okay.
So it's essentially ABC in the reverse order. So R comes at the end, then it's a P, then an I, then a G, and then a B. Okay?
Oh, okay, I understand. Okay, okay.
Okay, so the alphabetical order is reversed. So it's in a
Okay.
descending order now. Okay, so back to the shell. I should have done the length function at the beginning, but I forgot to do it. So this is the last function we're going to try on a list. If you want to find the length of a list, you can simply write len and the name of the list, and it would show you what the length is.
Teacher, ma'am, when you write like the length of the list, this is like all of the colors, like how many colors there are in the list?
Yes, or how many elements there are. So if there were numbers or if there was anything in the list, it would tell you, like for example, when you write a list on a piece of paper and you number it, right? So this is the same way that it's telling you how many things you have on your list.
Okay.
Okay.
Roop, I have a question. When we
Yes.
type a command like append or even length, it like shows you some suggestions, right? So like if we type length, it would show us a suggestion object, comma, and a slash. So like if you just type len, oh, it
Yeah.
does not show you a suggested wo.
No, it doesn't. Again, it depends. For example, I'm using idle. If you're using a different shell, it's probably going to show you the
Yeah,
option.
it's just the version 3. Yours is 3.9.1 minus 3.9.2. But my point is that are there like different input arguments that we can give to the shell? Like
Yes.
we're just
Yes.
inputting length, bracket colors, right? So
Yes.
colors, comma, what else can we input over there?
I'm not sure. Again, I'll have to look into it. I can get back to you about, regarding it. But yes, there are multiple. The same way that you see, we use the sort command. Now, when we didn't give it any argument, it sorted it using the default arguments. When we told it to sort reverse equals true, so it sorted it using this specific argument. So you can give any command or any function really a number of arguments. It's your choice whether you want to give them or not, whether you want to go with the default or you want to change the defaults. So there would be multiple things that you can add to every function, multiple arguments. It's just if you want to change the defaults or tweak them, you can add them. Otherwise, you just let it be as it is.
And I think that could be a good activity for all of us to look into the different arguments that we can use. For example, even with append or other commands, there's an option like you can input more arguments. So yeah, I think we
Yes.
could look into it as a class.
Yes, you can do that. Maybe we can do that, as an exercise or something.
Yeah, that'd be nice. Well, thank
Yeah.
you.
You're welcome. Okay, so any questions regarding lists or should we move on to tuples? Okay, let's move on. Okay, so do you remember the basic difference between a list and a tuple? So there was a difference in the way that we created it, one, and then there was a difference in the way that it functioned, right? So do you remember what they were?
Ma'am, I didn't hear you. The difference between tuple and what?
On a list.
A tuple on a list.
Yeah.
I think when you were writing, when you were showing us in the slides, you wrote like something like part A and part B, and then you wrote like some alphabetical letters. And then you used to write like part A slash part B is equal to sort, and then like it's sorted, and then like minus. It used to like minus the things that were in double mode.
Okay, that
And
was
then-
for sets. That was for sets. That wasn't for tuples. So do you remember what tuples were? What about the rest?
Can't
Tuples
delete
are
anything
like
from
a
there.
list, and it does not assign any specific index position, I guess, to the tuple as compared
Okay,
to
no,
list.
that was a set as well. So a
And
set does
that was
not
also
have
true
a
with sets, yes.
yes. So
And we cannot change perhaps the entries of the list in tuple?
Yes. So the major difference is really that once you've created a tuple, you can add elements to it or delete elements from it or change elements within it. Okay, so the way that you would create it was the same way essentially as a list, except that you would use round brackets instead of square brackets. Okay, so the difference between the way that you created lists and tuples and sets was that lists were created using square brackets, tuples were created using round brackets, and sets were created using the curly brackets. Muhammad Azam, you raised your hand. Did you have a question?
No, sorry, I was just like testing. It's actually one of my first times in Zoom. I use another application for calls. That's why I just want to test.
Okay, that's okay. Okay, so let's see. Let's give it a name. Or let's do it with numbers this time. Okay, so ages, because we worked with strings all this while, so let's work with numbers. Okay, so let's say we create this and then we print it out. So this is what we get. So it's showing us the round brackets in the printed output as well, which essentially tells Python and tells us as well that it's a tuple and it's not a list.
Ma'am, a question. Instead, do you have to write print ages? Like, if even if you like only write ages, will all of these numbers come?
It depends with different versions. I think it should. Yes.
Yeah, it works. So
Because
I
in the
think
older versions, you had to write longer commands. In the newer versions, you can work with shorter ones.
yeah, I think you should for me, I think you should only write ages. It will be more
Okay.
easy.
Yeah, it's easy because like generally users of Python say, it's, you know, they kind of like lazy programmers, so they want to limit the number of things that they're writing on the screen or in the script. So that's how, and that's why the different functions, they change their syntaxes and they change how
And ma'am, you can
use
write
them.
it in all ways. You can like print bracket ages. You can just write ages with no brackets. You can write print ages without no brackets, or like ages alone with brackets. Like always will work.
Yes, it would. Yes, in the versions that you are using now, all of these would not work in the older versions. So that's how updates work. So they've given you more functionality in the new versions, and all of these commands would not have some of them might have given you an error in the last ones. Okay. Okay, so let's see if it can, essentially it should not be able to remove elements from this. Okay, so it says tuple object has no attribute pop, which essentially means that you cannot use the pop command on the tuple object. So we used the pop command on the list and it did not give us an error earlier. But we cannot use it on a tuple because we can't change the elements within a tuple. And we can't add anything to it or delete anything from it. Okay, so what are, because we've gone through lists, can you suggest some of the commands that you would want to try on the tuple? Because I don't want to go through the whole set of commands again. It's just going to take up a lot of time. So please share what you think we should go through, and then we can go through those ones.
Teacher, can you like explain what tuples are again? Like I forgot some things.
Okay, so tuples are essentially
And can you like give
lists.
some exercises in the shell? So like,
Okay, so tuples are essentially the same as lists, except, you know, for the lists, you could have added more values, or you could have taken out values from the list,
Yes.
elements from the
Yeah.
list. With the tuple, once you've created it, you cannot change it. So it's fixed. It's like a fixed list. So you can't delete things from it, or you can't add things to it.
Wait, you mean like whenever like I go to idle shell and I go to like a very like pass command like print colors, like why if I erase it, there's like a sound like that.
Okay, I couldn't hear it.
It's like a Windows sound like
Okay. I don't know why that is.
like that.
Okay. Mosina, could you hear it? Because somehow I'm unable to hear it.
No, I couldn't hear it as well. Are you referring to an error, Assam? Because
Yeah, there's like a Windows sound. It comes like whenever like I erase something in the past. Like I try to, like it doesn't erase, and there's like a sound.
yeah, because that's just telling you that it's not possible. You
Okay.
can't do that in the shell.
Okay, yeah. So anything that you've already written on the shell, you can't really erase it or clear it simply by using backspace or delete. Okay. So we tried the pop function, and you notice that it tells you that since this is a tuple object, it does not have the attribute pop. So you essentially cannot use the function pop. The same way that you access different indexes on lists, you can access the different indexes on tuples as well. So ages, and so this is index number 2, 0, 1, 2, and this is what it prints. Or you can print a range of indexes, or you can print the last one, which is -1, and we print the last one, which was a 27. Okay, what else? I believe you can also sort them. Okay, no, you can't sort them either, because yes, the indexes are fixed as well, so you can't sort them. You can find out the length. Again, the length function works for tuples as well. So it would give you the length of the tuple. I've shown you how you can access the different elements. I've shown you that you cannot sort, or you cannot add, or you cannot delete elements from a tuple. What else should we try? Or should we move on to
Ma'am, how about like deleting ages like DEL and like bracket ages?
yeah. So then it deletes it essentially. So it's going to give you an error now because you deleted that. So there was a clear command which essentially cleared everything in a list. You cannot use it for a tuple again because you cannot clear the elements within it. But if you delete the whole tuple and then you try to print it, it's going to say name ages, that is, that variable is not defined. So it's not in its memory any longer.
So now we have to tell him what like ages is, then he will tell.
Yes. So now we have to declare ages again, give it another value, and then we can try and print it. Okay. So again, tuples are, there's not a lot of functionality that you can have with tuples, but they're generally used when you're working with data that you don't want to be messed up. So you can make copies of it in the form of a list and then work on it. But if you want your original data to be saved as it is in that particular format, you can save it in the form of tuple. Okay, we're going to move on to sets, and then if you have any more questions about tuples, we can come back to those. So again, sets are similar to lists. Sets are also immutable, so you can't add or delete anything to it once it's
So
been
ma'am, now
made.
like can you write like ages? What is like ages? Ages is like that.
Okay, I'm going to write ages as a set now. Okay,
Ages is what?
as a set now. So we're going to create a set by the name of ages. Okay, so yes, the elements within a set are changeable, but the whole set, okay, I'll have to check. I think I'm mixing it up with the others as well. Okay, the elements itself are not changeable, but you can add or delete things to a set. So let's say we create a set, we put in more ages. Okay, so we've created a set now. If you notice, when we created a list, we used square brackets. I've been repeating this multiple times because there's very slight differences in syntax that actually change the whole data type that you're using. So when we were declaring lists, we use square brackets. When we were declaring tuples, we use round brackets. And when we're declaring sets, we use these curly brackets. These are the curly brackets. Okay. And I'm going to repeat again because I got it confused myself the last time. So you can add or delete things from a set, but you cannot change the values. Okay. So you cannot change what's already there, but you can add or delete things from the set. And one other difference between a set and an index and a set and a list and a tuple is that within sets, there are no fixed positions for what's in there. So when you print ages now, it's going to print in a random order. So if you notice, when you created it, the first position was a 42, then a 30, then an 11, then a 25, and so on. But when you print it, it prints in a completely different order. If you print it again, it should probably print it in another order. Okay, now it's printed in the same order, but essentially
Ma'am, I have a question.
Yes.
Ma'am, if you write like the things like print and the bracket you used before for 42, 30, 11, 25, 36, what is that bracket called?
Curly bracket?
Yeah, okay, curly bracket. If you write print in curly bracket and print like curly bracket ages, what will happen then?
It should give you an error.
And how about like when you use
syntax error?
How about when you use the what do you call it, the rectangle one, like
the
print,
square brackets?
Yeah,
the square brackets would also give you an error, because for Python, it knows that whenever it's using the print command or any function commands, really, it works with round brackets. So if you use any other brackets, it's going to give you an error.
Okay. Actually, I don't understand why, like, they're all kind of brackets. I think it's because each bracket has its own, like, job.
Yeah, kind of, yes. The same way that we said that Python is case sensitive. So if you write print in capital letters, it won't know what to do. Okay.
And another thing, like Python, even a small single mistake, it will still like the red thing will come, a warning will come.
Yes,
A
that's
very like a small thing.
that's actually true for all programming languages, and uh, it's actually good for us as well, because this means that it tried running it, but it found an error and then it did not run it. So it did not give you any results or anything of the sort, because it did
Okay.
not run the actual script or the actual
Okay,
command
thank
that you
you.
gave. You're welcome. Okay, so now let's say we're going to make another set, and then we're going to do the union and the intersection and stuff. Okay, so ages 2, and I'm sorry, it was supposed to be curly brackets. Okay, so if you notice, I've kept some values similar and some different. Okay. In fact, I think there's only one similar. But okay, now we're going to try the intersection and the union and the difference that we studied about. Okay, so we're going to start with the union. What does the union do?
I think it sorts it out, or like maybe it minuses or subtracts the
No,
ones
so
that
a
are in double.
union, if you, it's taken from the regular English language essentially that we use. So a union is a combination. So what it would do
You mean
is
like
it would,
adding?
yes, so it would add the two sets, but it would remove the repeated elements.
Oh yeah, I remember you explained it when you like part A is like AEIOU and part B
Yes,
AE are like the A and the E and like they were removed because they were in doubles and only the IGH was left, and for the part B like Z and I don't remember the like the rest, but I no
yeah,
yeah.
yeah. So yes, it combines the two sets and it removes what the doubles. So it keeps one copy of the doubles and removes the rest. Okay, so we have two sets. The first one is ages. It has a length of 6. The second one is ages underscore 2, and it has a length of 6 as well. And I'm going to find out what the union of the two is. Okay, so I'm going to use the union command. You can simply use this one as well, or maybe we can try both. Okay, okay, so ages union ages underscore 2.
Ma'am, how do you write that union thing?
Okay, if you see above your enter key, there's a key that has a slash, and above it it's a straight line.
Yeah, I
So
see it.
you can use shift and press that key, and it's
Yeah,
going
I
to,
pressed it. Okay, okay.
okay,
Ages and agents too. Teacher, ma'am, do you mean like these are combined now, and
yeah,
like
so it's combined this now. Yes,
and the doubles they're erased? Ages and ages two. Okay, it came.
okay, so
Thank
if we find, I should have done this earlier as well, but let's say we do this now. So it gives you the length of the combined set, which is a 10. Okay, so there were repeats that it's deleted. Okay, so what was repeated? 30 and 25. Okay, so if you notice, 25 was there in ages as well, and it's in ages 2 as well. And then 30 is in ages and ages 2 as well. So when you did a union, it just kept one copy of the 30 and the 25. It deleted the other copy, which is why when we combine them, the total length of the new set is 10 instead of a 12. Okay.
Okay, I
And
remember you were explaining this in the slides with the part A
yes,
and part B.
yes. And I agree with Mohsena. I really appreciated that Muhammad Azam is, putting so much energy into this and asking all these questions, because they're helping me, they're helping all of you understand it better. But it would be great if the rest of you can, join in the discussion as well, ask questions, or even let us know if you're, understanding it, or however, it's going for you guys. But your input is going to help us. Okay, so now we're going to try another method, which was the intersection. So what the intersection does is gives us the common elements. So if you noticed, there were only two common elements in the two sets. Okay, so let's see if that is what intersection gives us. So the same way, using the same syntax as we did for union, except that we use the AND operator, we do an intersection, and it gives us a 25 and 30. So the intersection set is the common elements, and the common elements between the two sets were 25 and 30. Okay. Then there was the difference function, and the difference function was simply used as a subtraction. So let's say we do ages minus ages underscore 2, and it gives us the result of what it would be if we took out all the elements of ages 2 from ages.
Oh, you mean like when it like subtracted a 25, 25, like for example, the IGH you showed in the slide, this is like what happened.
Yeah, so it subtracted
Just like
the
that.
common elements.
Yeah, and now these are the ones that like are not doubled.
Yes, so these are the ones that are left in the set now. That is an intersection. Oh, sorry, that is a difference. Okay. So should we move on to dictionaries? Go back to the slides, because I think we've done all the basics that we learned for lists and tuples and sets. And okay, I got a message from Shahrukh saying, can you explain this one again, please? Can you specify which one, please, Shahrukh? You mean the whole of sets, or the union function, or the subtraction part? Okay, so I'm going to print the sets. So I can, it's all there in our view. So this was the first set. And this was the second set. Now, essentially, when you subtract one set from another, what it does is that any values, so I'm going to do ages minus ages underscore 2. Okay, so any values, this is going to be the main set, and any values that it found in ages 2 that were the same as the main set, it's going to delete them from the main set. Okay, so 52, it didn't find it there, so it's just going to ignore it. 40, it didn't find it there, it's going to ignore it. 25, it found it in the other set, so it's going to cross it out. Okay, 60, it did not find it there, so it's simply going to ignore it. 30, it found it in the main set, so it's going to cross it out. 15, it did not find it there, so it's going to ignore it. So now what's left in the main set is the 36, 54, 42, and 11. Okay. So if you notice again, it's not printed in the same order. That's because sets do not have a particular order. They can be saved in the memory in any order. So essentially what it does is that it cancels out or deletes the common elements between the two sets and gives you a difference, the same way it would do in maths. Okay, I am going to stop sharing this screen and share the slides again. And we're going to move on to dictionaries. We will definitely not be able to do a lot of the lesson of the actual planned lesson today. But it's okay. I was also discussing with Mohsena earlier if, because obviously we gave you a certain, list of things that you would be doing over this entire 5-week course. And we have been taking it slow so that it's not very overwhelming, but that also means that we would not be able to finish everything that we've planned. So if it would be okay with KSS, and also it would be okay with you guys, we might need to add in one more lesson, so extend it a week, so that we can cover up all that we've planned. So let us know what you think about that. You can either email us your suggestions or leave them in the chat, or you can get in touch with Mohsena separately and let her know. But I really want you to, grasp all the concepts that you're actually studying. Okay, so moving on. Another data type in Python is dictionaries. Now, dictionaries are again like lists, except that in lists and tuples and sets, or maybe not sets, but lists and tuples, we had index numbers. So everything was saved at an index 0 or 1 or 2 or 3 and so on. In dictionaries, the index numbers are replaced by keys, essentially. So instead of a 0, you would give it a value. So you would give it a name, not a value. You would give it a name. So that would be called the key. And then whatever is in that key would be the value. So it is a collection of key value pairs. For example, here it's shown a dictionary that has fruits as its main name. The first index is called value, and its value is tomato. The second index is called key, and its value is red. So it's not the
Ma'am,
best.
but this instead of key, why didn't they write color? Like,
Yeah,
why did
they should have used a different name for
word?
it. We're going to try and use it
Yeah.
in the shell. Okay, and you can use a key to access the value associated with that key. So a key's value can be a number, a string, a list, or it can even be another dictionary. And the same way as sets are written, dictionaries are written using curly brackets. Okay.
Okay, ma'am.
Okay, so here, if you see on the side, it shows you two examples of dictionaries. So the first one has the name months. The key values are the short forms of the names. So Jan, Feb, March, April, May, June, July, August, September. And then the values themselves are the complete names of the months. Okay. So these here on the left are the keys, and these here on the right are their values. The second dictionary is weekdays. Here they're telling you that you can also use numbers as keys. So you can use strings as keys, or you can use numbers as keys. So this would not be the same as indexes, because indexes always start at 0, remember. Here you can put in any numbers. written 1, 2, 3, 4, 5, 6, 7, but it can be any random numbers really that you want to put in. And the values they've saved to them are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So they've given these key value pairs. So here the keys are the numbers and the values are the names of the days. Okay. The keys in a dictionary, there are some rules now that you need to remember for a dictionary. The keys in a dictionary must be unique. So the value that you assign to it, it can be the same. But the keys here, the things on the left-hand side, cannot repeat, because then it's just going to be a huge confusion. So then if you try to access something using the key, it wouldn't know if you're trying to access the first element or the last element or any element in between or which one exactly. So the keys in a dictionary must be unique. You cannot have two same keys. Secondly, the keys are immutable. So once you've given names to the keys, you cannot change their names. You can change the values inside them, but you cannot change the names of the keys. Okay. The keys and values can be of any data type. So like they've given an example here, they can be numbers, they can be strings, they can be anything really. Now there are two functions here, and then there's more functions that we'll be looking at in the remaining slides. So there's a keys function which returns a list of keys in a dictionary. So it would show you all the keys that are present. It won't give you the values, just the keys. And then there's the values function which returns a list of values. So it doesn't give you the keys, just the values. Then a lot of the functions or the methods are similar to the ones that we used in lists, clear, copy, and then from keys returns a dictionary with the specified keys and values. This is essentially if you have multiple dictionaries in there. Get, if you give it an argument based on a key, it would give you the value for that particular key. Okay. Then items returns a list containing a tuple for each key value pair. So this is a way to convert it into a tuple. Keys again returns the keys. Values returns the values. Then there's a pop function. You can use this in here. Pop item. So like in the last one, in the list, when you use the pop function, it automatically removed the last element. Here, if you want to remove the last element, you use the pop item function. So it's slightly different. And these are things that you would need to remember essentially. And they would, once you start using them, they would come in your flow, and then they would just be in your memory as is. So here in the pop function, we're supposed to give it an argument. So we're supposed to tell it what we want to pop or what we want to remove. So pop, and then we give it the key, and it's going to remove that key. Okay. Then set default, we're going to skip through this. We don't usually need this unless we're working with dictionaries a lot, and update as well. Okay, so these are some points to remember again about lists, tuples, sets, and dictionaries. So a list is ordered and changeable, and it can have duplicate members. A tuple is ordered and unchangeable, so you can't change it, but it still allows duplicate members. A set is unordered and unindexed. So there is no particular order to what you've put in the set. You've added elements in a different order, and when you print it, it's going to show you a different order. But it's important to remember that there can be no duplicate members within a set. And a dictionary is unordered. So again, like a set, it's unordered, but it's indexed because it's indexed based on the keys, and it's changeable. The keys themselves are not changeable, but you can add things to a dictionary, you can delete things from a dictionary, and you can change the values. Again, for a dictionary, the keys cannot be duplicated. So you cannot have two of the same keys. They have to be unique. Okay. This also summarizes, in one slide, really, how you can create a list, a set, a tuple, and a dictionary. And it shows you some basics like append, pop, add items to a set. So essentially adds them to every element of the set, removes tuples, and then dictionaries and adding things to a dictionary. Okay, we are going to try and work with the dictionary as well on the shell, but first let's see what else is left. Okay. Mohsena, this is an entirely new topic now. The conditional blocks and statements. Should we, because there's just 15 minutes left, should
I think you should demonstrate some examples with dictionaries.
and
We
then we
should
take this to the next one?
Yeah, we should start this in the next lesson. So if you had something related to this in the exercises, then you do not need to change the slides. I guess we can just tell the students to not do those.
Yes, and yeah, that's what I did last time as well. I just told them not to do the last exercise and do the remaining ones of them. And yes, from these ones as well, I'll just tell them which ones they can do and they can try those.
You can tell that later. For now, if you could just show some examples with dictionaries, that would be great.
Yes, we can try and create a dictionary in the shell.
Yeah.
And yeah. Okay.
Can anyone hear me?
Yes.
Why is it so quiet?
Why is it so quiet?
Yeah.
I'm not sure. I was just opening up my shell, but otherwise I'm not sure.
Okay.
Yeah. Okay, so let's say we make a dictionary of fruits and we put in a few entries, okay? So remember that each entry is supposed to be a key and a value pair. So let's say we do the key can be yellow. And since it's a string, it has to be within inverted commas, then a colon, and its value is going to be a banana. Okay, so this is one pair. Then we add another pair. So red, and let's do a strawberry. So I'm not going to put in an orange again because that's just going to confuse you. So I'm going to put in a clementine. Okay, so it's a kind of an orange. So we're not going to make it very long. So let's say this is what. Okay, I messed it up somewhere. Oh, because I did not put an equals to sign. My bad. I'm sorry about that. So yes, to declare it, you need an equals to sign. So fruits equals to this. Okay. So I've used there's essentially 4 elements in the dictionary, and all the keys are given on the left side for each element, and then the values are given on the right side. Okay. So now if we print this, this is how it prints. Okay. Now, if you want to find out what the keys are and what the values are, we use the keys and the values functions. So fruits.keys and fruits.values. So if you notice now, the first function gave us back just the keys. So the keys were yellow, red, orange, and green. Yellow, red, orange, and green. And the values were banana, strawberry, clementine, and watermelon. Okay. Any
Nope.
confusion? Yeah.
In the examples you showed, they had indented the dictionary values and keys. So could you write the dictionary in that form instead of in a single line and a comma?
Okay. For that, we would have to write it in a script file.
Oh, okay, okay.
Yeah, because when we're working in the shell, it's difficult to write it like that unless you use, the slash operator.
All right.
Yeah.
Okay, we could use a slash operator for that.
Yeah.
Thank you.
You're welcome. Okay, so if you want to, let's say access certain elements. How would you do that? For example, if you want to access certain elements or find out what's at certain key positions within a dictionary, how would you do that? So there's a function by the name of get. So fruits dot get, and then let's say you want the value of whatever is in the key orange. Okay, and it's going to give you clementine. So fruits.get needs an argument inside it where you tell it what the key is, and you're basically telling it to get you whatever is available at that particular key. So it's the same as using an index. So for lists or for tuples, you would have written fruits and then square brackets and the index. But here, since there's no index numbers, you give the value of the key. Okay.
So one question.
Yeah.
How does the compiler differentiate between dictionary and I don't know what was the other thing, sets,
With the
whatever
curly bracket. Yeah.
yeah.
Because
Is it the first colon position?
yes, because of the colon. So
Yeah.
because of the
Yeah,
colon,
okay.
it knows that you're giving it a pair of values.
Yeah.
So with
Okay.
sets, you wouldn't be giving it a pair.
Yeah. Yeah.
Yeah.
Thank you.
You're welcome.
Ma'am, is class over?
Let's just try and do 1 or 2 more functions, and then we can, I'll let you know how to do the exercises, and then you can leave. So we still have 5 minutes.
Actually, we only have 3 minutes left.
Okay, just give me a minute more, one last function, and then we can move on. And the rest of the functions you can experiment with on your own. Okay, so let's say you want to delete an entry from your dictionary. So again, what you give it is the key. So you tell it that you want to delete that particular key. So fruits, and let's say we want to delete green. Okay, so now when you print fruits, that entry got deleted. Okay, so for most functions on dictionaries, what it needs as an argument is the key. So for example, when you need to get a value, you use the key. When you need to delete a particular element, you need to know the key. And if you want to know what the different keys are, you can again find them using the keys function, and the values using the values function. Okay, then there are different ways to check if a value exists within a dictionary or within a list or within a set, or it does not. That was going to be a part of this lesson, but I think we're going to do that in the next lesson now. I'm going to close the shell and go back to the slides. And show you the exercises. We're going to do all of this in the next lesson now. And there are some exercises that you can still do today. Other than that, I would like you to try out the different functions that are listed in the slides, because I did not get a chance to, go through each and every one of them. Just try them out. And like Mohsina said, if you're using a different compiler or a different shell, like I was using the idle shell, if you're using PyCharm or you're using Sublime Text or anything other than idle, you would probably see a list of options when you type in a function name. So explore what that list of options is, what different parameters you can give it. And here are the exercises. Again, try these out. You don't necessarily have to send me a screenshot of the code. So thank you for your time today, and we'll inshallah be meeting next Saturday. And meanwhile, again, I'm going to repeat myself. If you have any questions, just drop us a message.